Welcome back to the series, Part 18, and this time we're giving the machine ears and a voice. The plan is simple: speech in, speech out, with a local LLM doing the thinking in the middle and not a single byte heading off to anyone's cloud. We'll lean on Whisper for transcription and Piper for synthesis, stitching together the full 5-step loop entirely on your own hardware. Now, cloud speech APIs exist and they're cheapish, so why bother going local? 4 reasons. Your voice, calls, dictation, half-mumbled meeting notes never leaves the box, so there's no terms of service clause quietly training someone's model on you. It's free at any volume. Transcribe 10,000 hours and the bill is still zero. It works on a plane or in a basement. And for short clips, a small Whisper model on GPU finishes faster than the audio plays. No cloud round trip can touch that. So here's the spine of the whole thing. 5 steps. Record audio off the mic with SOX or Aracord, hand the wave to Whisper for transcription, post the text to Ollama's chat endpoint, pipe the reply through Piper to synthesize speech, then push the resulting wave out through aplay. 4 of those 5 are just command line tools, and step 3 is the ollama you've already got running from earlier in the series. The glue is whatever you're comfortable with. A bash script works, Python works, take your pick. Setup is mercifully short. Grab Fmpeg, SOX, and AlsaUtils from app for the audio plumbing, then pip install OpenAI, Whisper, and Piper TTs. Both will pull their model weights down on first run, so don't panic when that initial invocation takes a minute. Quick smoke test. Record 5 seconds off the mic with SOX, feed it to Whisper with the small model, and you'll get back a transcript plus JSON and SRT sidecars. CPU works fine, but a GPU will run this 5 to 10 times faster if you've got one. Now about that small model I just casually dropped. Here's why. Whisper ships in 5 sizes and they trade accuracy for RAM and speed pretty linearly. Tiny and base are basically toys, fine for keyword spotting, but they'll mangle anything with an accent. Small is the sweet spot for English at around 460 megs and 3 times real-time on CPU. If you're transcribing Hungarian or other non-English audio, jump to medium. Large V3 is gorgeous, but really wants a GPU to stay usable. Now, OpenAI Whisper itself is fine for prototyping, but for anything you actually deploy, switch to faster Whisper. Same models, same weights, but it's a C-Translate 2 reimplementation that runs roughly 4 times faster on CPU and uses about half the RAM. The API is almost identical. You import Whisper model, pick your size, and crucially set compute type to INT8 for CPU work. That quantization is where most of the speedup comes from, and accuracy loss is negligible. From here on out, this is what we'll wire into the voice loop. With speech-to-text handled, we jump to the other end of the loop, turning the LLM's reply back into audio. Piper is the obvious pick here. The voice models are tiny, 50 to 100 megs of ONNX, and they run comfortably even on a Raspberry Pi. Workflow is exactly what you'd hope. Download a voice once, then pipe text into the Piper command and either write a WAV file or better, stream raw PCM straight into a play so there's no disk round trip and no perceptible latency. And here's the whole spine of the talk in about 30 lines of Python. SOX grabs 5 seconds from the default mic at 16K, faster Whisper turns it into text, that text gets posted to Ollama running Llama 3.1 on localhost, and the response gets piped through Piper into a play. That's it. Mic to STT to LLM to TTS to speakers, all local, no API keys, no network calls leaving the box. Hands-free assistant unlocked. Now, before you get too excited, let's talk about the elephant in the room. Latency. On a typical CPU laptop, you're looking at roughly 4.5 seconds of dead air after the recording stops. Whisper eats about 1.5, Ollama burns 2.5 getting through its first 50 tokens, and Piper barely registers. The good news? Throw a GPU at Whisper and it drops to 300 milliseconds, and if you stream Ollama's output token by token into Piper, the assistant starts talking back in about half a second. Together, those 2 changes cut felt latency in half. While we're trimming fat off that loop, let's fix another annoyance. the hard-coded 5-second recording window. If you finish your question in 2 seconds, you're sitting there waiting. If you need 7, you get cut off mid-thought. Voice activity detection solves both. You can pull in silero-vad for the fancy neural approach, or just lean on SOX's built-in silence detection, start recording when volume crosses 1%, stop after 1.5 seconds of quiet below 2%. Speak naturally, pause, done. Speaking of pauses, let me save you the bruises I collected building this. 5 traps, each one cost me an evening. Sample rate mismatch. Whisper wants 16 kHz, your mic probably gives 44.1, and the output will be pure gibberish. Whisper also hallucinates on silence, inventing phantom sentences, which is exactly why VAD matters. Piper installs to bot local doc bin and won't be on path by default. Ollama streams tokens, but Piper needs full sentences, so buffer to punctuation before synthesizing. And on Pulse Audio, check Paview Control's recording tab. Sandboxed apps silently get denied mic access more often than you'd think. Now that you know the traps, here are 4 projects small enough to actually finish tonight. Start with the voice loop itself. 30 lines, push to talk, end-to-end proof it works. Or wire up a meeting transcriber that pipes faster whisper into an LLM for action items. The dictation hotkey is the one I use daily. Hold a key, talk, release, and the text appears in whatever window has focus and subtitles. Point whisper at any MP4, get an SRT, burn it in with FFmpeg, pick one, ship it. Real usage is where you find the real bottlenecks. Before you wire voice into everything, a quick reality check. There are cases where typing just wins. Code and exact strings are the obvious one. Ask Whisper for an IPv4 regex and you'll get something that almost compiles. The 5-step loop also costs you 4+ seconds round trip, so for a quick lookup your fingers beat your mouth. And noisy environments, cafes, trains, a toddler nearby, tank Whisper's accuracy fast. Headset mic or fallback to keys. So let's tie it all together. The spine of everything we built is that 5-stage loop. Mic, whisper, ollama, Piper speakers, and 4 of those stages are just CLI tools you can glue with 20 lines of bash. Whisper small under faster whisper with INT8 hits the sweet spot on CPU. Piper voices are tiny enough to run on a Pi, and there's a Hungarian one waiting on Hugging Face. VAD is the unsung hero that makes it feel natural, and budget about 4 seconds end-to-end on CPU. Half that if you stream tokens sentence by sentence into Piper instead of waiting for the full reply. And here's the page worth bookmarking. 12 commands that cover 90% of what you'll actually type. The left column is your STT and capture stack. OpenAI Whisper or Faster Whisper with INT8 quantization, SOX for the mic, silero-vad when SOX's built-in silence detection isn't sharp enough. The right column handles synthesis and the knobs that matter, Piper with an ONNX voice, the language flag for multilingual setups, and that roughly 4-second budget to sanity check your own loop against. That wraps the voice loop, mic, STT, LLM, TTS, speakers, all running on your own hardware with nothing leaving the box. Next time we pivot from voice to text as API, Part 19. Tackles Ollama's OpenAI-compatible endpoint, where one environment variable export quietly redirects langchain, continue, cursor, and every old script you've got straight at localhost. No rewrites, no API bills. See you there.